we're going to work on simplifying radicals. So they've given us this triangle here, and they want us to express it in the simplest radical form. So the first thing we have to do, they want us to express the area. We should really state that. So we need to find the area of this in the simplest radical form. So the first thing we have to really establish is how to find the area of a triangle. So let's just bring up a small triangle here on the side and talk about how to find the area. In order to find the area of a triangle, you need the height. And luckily, they've given us the height here. Okay? So the area of the height of a triangle is the base times the height. Okay? So we'll say area of a triangle is base times height, but divided by 2 because it's only half a square, right? So with that being said, we have those types of things. We have a base. Our base in this question is root 10. We have a height. Our height in this question is root 20 over 2. And 2 is 2. So we're going to do the exact same thing. We're going to build an area here. So area of a triangle is equal to. So we're going to replace base. Okay. So instead of writing in base, we're going to write in root 10. And we're going to replace the height with root 20 over 2. Okay. Well, I don't want that one. Let's say root 20 over 2. And then all of this is divided by 2. So I could write it like a large fraction. It's not a good one. Let's use a solid. I could write it like a large fraction with numbers on top, but that might get a little confusing. Okay, so there's a rule in math called associative property where you can multiply and divide really in any order you want. So instead of writing it that way, let's get rid of it. I'm just going to kind of write divided by 2 over here. Okay, we're going to establish this and then figure out this other part after. Okay, so think of it like we're, or actually another way. Do you know what's another way of writing divided by 2? What can we multiply
times
by?
0.5.
Yeah, times 0.5. Or as a fraction, we can say times a half. Yeah, so let's do that instead because we're already working with fractions. So let's multiply by a half. And that'll make this a lot easier to look at. Okay. So when we're multiplying fractions, you do, let's make root 10 a fraction. Do you know how I can make that a fraction?
Yeah.
It's over something. Do you know what number it's technically over, even though it's not showing it?
1.
Yeah. So now we're working with fractions, so we can kind of apply our fraction rules. We're going to multiply all the top values by each other and all the bottom values. So all the denominators by each other and all the numerators. So instead of actually equating them, we're just going to write them together in one large fraction. So we have root 10 times root 20 times 1, which is fine. We can write it in. It's not going to do anything. It's not going to make any difference for us. And on the bottom, we're going to have 1 times 2 times 2. So 2 times 2 is 4. Yeah, so we're just going to have 4 on the bottom. And I'll talk about how we could have got the 4 really quickly before, but anyways. So this one's really not important, so I'm not going to include it. We're going to write it out. So we've kind of simplified. We've done all the multiplication part. We need to simplify these radicals. So when we simplify radicals, usually you're looking for values that have, and this one's a square root. Even though they haven't written anything here, there's usually a 2 that represents it, so you're looking for 2 numbers that multiply. So when we're trying to split these up, you're usually looking for numbers that you can actually find the square root of. And those types of numbers are like 4, because the square root of 4 is 2. 9 is a good one, it gives you 3, 16, yeah. So any of those values, if you can use those as factors of these, they're really, really helpful. If not, it's not the end of the world.
I don't think you can get 10.
Yeah, you can, and you can't really, in the 10's not going to give us something. 20 will give us something that we can work with. So worst comes to worst, you can also try to find prime numbers. And if you guys, do you remember doing prime factorization at all?
They can be done for one of themselves.
Yeah, exactly. So you're looking for, you can essentially build prime factors of everything. So you can break all of these down into their primes and then kind of work your way up from there. And actually, you know what I'll do? I'll show you how we do that on the side. So let's say we had 10. Look for some prime factors instead of
5 and 2.
5 and 2. And both 5 and 2 are prime numbers, so that's it. That's as far as 10 can go. 20 gives us a little more.
10 and 2.
Yeah, 10 and 2.
5 and 4.
5 and... You're right. You could have just said 5 and 4, or if you break them into all their primes, it's 5, 2, and 2. So I'm actually going to break them into primes and then work our way up and then kind of show you a shortcut after that. So let's break this 10 up. This 10 here is now root 5 times root 2, okay? And the 20 is root 5 times root 2 times root 2. We're still keeping the square roots, okay? We haven't done anything with them. So that's root 5 times root 2 times root 2. So I've got a whole bunch of radicals on top. I've broken them all into their primes. And then we have the number 4 on the bottom. Well, the good part about this is I can combine prime numbers, roots, like root 5 and root 5. Root 5 times root 5 is just the number 5. Think of it like this. If I had root 9 times root 9, that would be 3 times 3, which is the equivalent of just 9. So instead of actually doing that extra step, we can just cancel out the roots, okay? So because I have 5 and 5, well, that just leaves me with the whole number 5, okay? So we have 5 times, well, we have 2 and 2, so those roots cancel out, so we have a whole number 2. And then we're left with one radical at the end, so radical 2, or root 2. And when we go to divide, it's still over 4. So we've done a lot of extra stuff on the side. We could have done this much quicker. 5 times 2 is 10. Okay, so we have 10 root 2 over 4. And then there's a number that goes into both 10 and 4. We can reduce these two values. 2, exactly. So when I divide both of them by 2, think of it like we're dividing both of these by 2. Okay, like you're dividing the top and the bottom of the fraction by 2. You end up with 5 root 2 over the number 2. And that would be the area of the triangle. That's what we're trying to kind of get at here. So we did a lot of extra stuff on the side, okay?